everybody, and welcome to the Valeri Analytics channel. I am Michael Valeri, and today's class is class number 5, case statements, also known as conditional statements in SQL. In last class, we talked about anti-joins, which are the inverse of a regular join, in which you find everything that's missing from either table A or table B. And we learned that anti-joins use the regular join command as a standard join, except you add the where clause if you're looking for the values that are missing between the two tables. Today's class is all about conditional statements, creating columns that say if column A and if column B and if column C meet these conditions, then return this value. This is really useful for grouping and categorizing data. So what I want you to do is jump in the SQL Analytics YouTube SQL Immersive curriculum folder and open up class number 5 case statements and open up student SQL Immersive guide class 427. We are going to be using this document in tandem with the class number 5 notes. So just open up your class 5 notes, and you're going to want to copy and paste that into Note Analytics, which I've done here. And then you're also going to want to have a copy of the Student SQL Immersive Guide class 4 to 7 open. As for myself, I have a teacher version. Before we jump into conditional statements, let's talk about an SQL review. Let's do a couple review questions before we go into a new topic, just to reinforce the learning of everything we've touched so far. We're going to start with a couple homework questions that weren't actually on the last homework, but I just saved them for this class, so we're going to do them together. So this question says we're going to use the mValeri trips and mValeri 12 customer marketing list tables to answer these two questions. Well, what do we know about SQL? Every query starts with select and from, so let's start there. Question 1 asks us, hey, I want to see the total number of trips for folks who rode on scooters, grouped by whether these people own a bike or not. So this person's obviously trying to find out, of all of our rides, of all the people who ride on Lime infrastructure, bikes and the scooters, how many of them personally own a bike or not? Well, what do we know here? Well, if we're talking about the company Lime Bike or Lime Scooter, the center of the universe is going to be the trips table. That's their transactions table. So I'm going to say that mvaleri12.trips is the center of the universe. It's table A. So I'm going to write trips as A. And our secondary table is the mvaleri12 customer marketing list table, in which we just get a list of customers and all of their demographic information, and that's going to be table B. I'll put a note here, secondary table, and table A is our first table, and it's the table on the left side of diagram. Second table is on the right side of the Venn diagram that we talked about in last class. So the question says, I want to see total trips grouped by bike ownership. Well, what is one of the columns or ingredients that we're going to want to see in the result output? Probably something called total trips, and whether this person owns bike or not. Owns bike or not. That's going to be the name of the column. Total trips. Does that sound like an aggregate or a dimension to you folks? To me, that sounds like an aggregation. So next to it, I'm going to write ag. Owns a bike or not. That is a qualitative piece of information. That is our dimension. What do we know when you mix aggregates with dimensions? You got to have a group by. So down below my joins, I'm going to write my group by clause, because that comes after from. And I'm going to put in the dimensions, owns a bike or not. What we've done here is we've just built the shell of our query. We're not really sure what's going to go into building these columns, but we know architecturally what our result output will look like, and we're just going to be seeing these two columns. A list of total trips, and then whether the person owned a bike or not. We should be seeing just 2 rows of data in our result output. First, let's take a look at the trips table independently to see how we can construct the total trips column. I'm going to do select star from mvaleri12.trips. We're going to take a look at it. All right, there we go. Each row in this table is a trip, a unique trip on a scooter or a bike. I actually opened up the schema here on the right. So this is a pretty detailed table telling us the day of the week of the trip, the time it was completed, rider ID, etc. Rider ID. That might be useful. That tells us actually who was on the scooter or the bike. Great. Manual scooter. Very cool. Electric. Okay, so if I'm going to want to see the total trips grouped by bike ownership, total trips, what table do you folks think that's going to come from? Well, based on my knowledge here, it looks like the trips table is going to list the unique number of trips. So that's going to come from our trips table, or it's known as table A. Total trips, how do we calculate that? Well, if we know every row in the trips table is a unique trip, then we can simply count A dot trip underscore ID as the total trips. Count is going to count the number of rows in a column that aren't null, and we know every row represents a trip, so that should give us the total trips. Easy peasy, lemon squeezy. Owns a bike or not. Now, in the trips table, I don't see a column that tells me whether the rider owns their own bike or not. Where do you think that's going to come from? My thought is that probably comes from select star from mvaleri12 dot customer marketing list. The customer marketing list is going to have that information in it. So let's open that up. All right, taking a look here. Has owned bike, true or false, and what do we have here? A list of the rider IDs. Rider ID is what allows the customer marketing list table to talk to the trips table. So we can join on the rider ID between these two tables. So let's try that. It says we want to see total trips grouped by bike ownership. Do you think it's possible that someone could have a trip but not be in the customer marketing list table? Absolutely. However, we want to see whether they own a bike or not. So we want to see if it's true or false for that rider. Because of this, we're going to do a left join because I want to see if there's people who are missing from the customer marketing list table in addition to the ones who own a bike or not, true or false. What does the left join say? Show me everything in the left-hand table, regardless if it's in table B or not. So let's be safe. Let's choose the left join to see if there's anyone that's null who isn't in the customer marketing list table. We're going to say on, and what column do the two tables have in common? It is rider ID. So we're going to say A.rider ID from the trips table. Can you join every row where it is equal to the B.rider ID in the customer marketing list table? So that is our join condition. Looks good to me. Owns a bike or not. What column is going to tell someone if they own a bike or not? It looks like this column has own bike. So the column B.has own bike is the Boolean column that tells us whether a rider is going to own a bike or not. You'll notice I'm aliasing it as owns own bike or not. I'm just renaming it. The group by, you'll notice I can recycle the alias in the group by because the group by runs after the select statement. Let's highlight and hit run selected and see if this works. Look at this. We have 203 trips where the person didn't own their own bike, 174 where they did, and 1723 where we don't know if they own their own bike or not. So what do these folks represent? Well, these are the folks that aren't in table B. We don't have a demographic information for them, so they just get lumped into null. So the left join, whenever you're doing a left join, if you can't find the information in B, we still return the value. So that's why doing a left join is really safe because it's going to categorize those things as null instead of eliminating them. If we did an inner join, we'd actually be eliminating that 1723 number from a result output. Let's look at question number 2. What is a distribution of people by age that haven't taken a ride? Ooh. So what we want to do here is we want to say, hey, show the age of a person and then count the number of people in that specific age that haven't ridden or taken a trip on one of our scooters, bikes, etc. What do we know about every SQL query? We need select and from. So that's the first thing we're going to write. Select and from. What is a primary table in this case? Well, we're using Valeri 12 trips and customer marketing list table. We know the trips table is the center of the universe. It's the most important table to the business. So Valeri 12.trips as A yet again. And what table do we want this to talk to? Well, we want to find people that are only in table B, which are people who aren't in the trips table. So let's put in the customer marketing list table here. As B. That's table B. Okay. If we want to find the people by age that haven't taken a ride, what are going to be the 2 columns that we want to look at? Well, one is going to be the count of people, no ride, count of people who haven't taken a ride, which to me sounds like a quantitative piece of information. It's an aggregate. And then we're going to want to see the age of that person. The count of people for no ride. How are we going to find this? Well, these are going to be the people that are only in B, not in A. What did we learn? If you want to find the people who are only in one table but not another, you need to do an exception join. And in this case, since you want to find the records that aren't in table A, that are only in the right table, the secondary table, you're going to do a right join. In particular, you can do a right exception join. So exception join, we set the primary key to the opposite value. We set the primary key of the opposite table to null. In this case, we only want to be looking at the right-hand table. It only can exist in table B, the customer marketing list table. So on the where clause, we're going to say where A, the left-hand table, rider ID, where A rider ID is null. And I realized something. I forgot to write on here. What do these 2 tables have in common? It's rider ID equals B dot rider ID. Again, if I could show you in the list, it is number 5, the right exception join. You can think of table A as the trips table and table B as the customer marketing list table. So we only want to look at the people who signed up for the list but didn't take a ride. That's the right exception join. That's why we set where A key is null. Let's go back here. So the age of the person, what table does that come from? Well, if I look at the customer marketing list table, that's where I'm going to get age, right? That's a dimension. That comes from table B, and I can actually show you customer marketing list table. See, you get age from there. And so we're going to write B dot. We're going to append the alias to the front of the column because there's more than 2 tables. SQL doesn't know which table it's coming from. So let's put a B in front of age. The count of people no ride. How are we going to find that? Well, we're only going to be looking at people in table B, so it's got to come from table B. So if I want to get the unique number of people from a table, I'm just going to pull select star from customer marketing list. Here we go. So if I was to count these values, the riders, every row is a unique person, that's going to give me the count of people. So let's write count B dot rider ID as the count of people who have not taken a ride. exception join was to the primary key, the opposite table, the null. Well, what happens when you mix an aggregate with a dimension, folks? You need a group by. So I got to put that down there. And only dimensions go in the group by, so I'm going to write age down here, b.age as my dimension. Let's highlight the code and run it and see if it works. Looks like something's wrong. Syntax error near null. I said where rider is null. Where rider ID is null. My bad. Let's try that again. Count of people no ride. Okay, so 2 18-year-olds have never taken a ride in our customer marketing list. 3 19-year-olds, etc., etc., etc. That's really helpful. Ooh, we have someone in our customer marketing list who is 65. Any age can ride a scooter or bike. It doesn't matter. So those are the SQL review questions. You'll notice that there were anti-joins in question 2, and question 1 was just a standard join. Get comfortable with anti-joins, also known as exception joins. And understand that they're just like a regular join, except you're going to use the where clause, and you're going to set the key of the opposite table to null. You want to consult the syntax, you're more than happy to. I would hang this at your desk, and I would just take a look at it whenever you can. It's really, really, really useful. So let's move on to case statements now. And before we jump into there, I want to conceptually talk about what a case statement is before we learn the syntax. I'm going to read this definition. The case statement goes through conditions and returns a value when the first condition is met, like an if-then-else. So if one condition is true, it will stop reading and return the result. And if no conditions are true, it will return the value in the else clause. What the hell does this mean? Let's go through an example of a case statement. A couple things to know about a case statement. 1, it goes in the select statement. I like to think of a case statement as an extension of the where clause that's been placed in the select statement. We can set a list of conditions, follows a very similar syntax to the where clause, and assigns a value based on whether those conditions are met or not. In this case, we're creating a column in our select statement called vehicle status, and the vehicle status is either going to return a result output of replace or keep the vehicle. And what we're trying to do is say, hey, if one of our vehicles have a high repair count, let's replace it. However, it depends on the type of vehicle that we're working with. For example, if it's an electric vehicle, we're going to want to replace it if it has a repair count of over 50. If it's a manual vehicle, we're going to want to replace it if it has a repair count of over 10. And if it's a scooter, we're going to want to... If it's electric, we're going to want to replace it if it's over 30, manual over 50, and scooter if it's over 10. So we have to look at 2 different criteria to determine which bucket it goes into, and this is why the conditional statement is really powerful. So we're just going to manually do this by evaluating how the case statement would behave on this repair table. So let's take a look at the first row. We have vehicle ID 12345, its repair count is 20, and its a vehicle type is electric. Let's look at the case statement and see what should be returned based on this criteria. So the case statement says when the repair count is greater than 30. Is the repair count greater than 30 for this row? Absolutely, that's true. So we move on to the next and condition. And the vehicle type equals electric. Folks, let's do this again. Is the repair count greater than 30 for this record? No. It's not. So actually this is false. So this first when condition fails. It's false. So we move on to the next when condition. When the when condition fails, we go to the next one. When the repair count is greater than 50. Is the repair count greater than 50 for this record? No, it is not. It's 20. So that fails. So we move on to the next when condition. When the repair count is greater than 10. Is the repair count greater than 10 here? Indeed it is. So actually this is true. But something else needs to be true, and it needs to be a scooter. So, is the repair count greater than 10 and it's a scooter? No, it's false. So this when condition fails, so it defaults to keep. This is a vehicle we don't need to repair. All of these failed. It's an okay vehicle to keep, so let's write keep next to it. Let's look at the next row of data. Repair count is 35. When a case statement evaluates one row of data, the case statement will restart on the next row of data. So we're going to start from the top again. When the repair count is greater than 30. Is the repair count greater than 30 here? Indeed it is. All right, that's true. What else needs to be true for this one condition? And the vehicle type equals electric, then replace. Are we going to replace this vehicle? Yes, both are true in this case, in this one condition, so we're going to replace it. All right, we move down to the next row of data. The case statement's going to restart. Is the repair count greater than 30 for this one? Indeed it is, but it is not an electric vehicle, so this one condition fails. Let's move on to the next one condition. Is the repair count greater than 50? Indeed it is. And is it a manual scooter? Yes, it is. Both are true, so we're going to replace it. All right, let's look at the last row of data here. Is the repair count greater than 30? Remember, we move on to the next row of data, and then the case statement restarts from the top. Repair count greater than 30. No, it's not. Fail. Move on to the next one condition. Repair count greater than 50. No, fail. When the repair count greater than 10. No, fail. We're going to keep this. Else keep. So you'll notice the else is what it will default to if everything's false. It puts it in that bucket. What syntax rules do case statements follow? It's like the where clause. So if you're familiar with all of the functionality of the where clause is just moving up into the select statement, and we're using it to create a column or a dimension. So these case statements create our own custom dimensions for us. Really cool. So let's hop in here and let's see if we can apply what we learned to a practical example. So we're going to use Lesson 5 Instructor Guided Case Statements. We're going to be using the MValeri 12 trips and customer marketing list table to answer this question. The exercise is called OK Millennial. Exercise 1 and 2. So let's hop into Teacher SQL Immersive Guide. And we're going to scroll on down to the workshop, which is on page 12. It's called OK Millennial. Let's read the prompt. The VP of Marketing at Lime wants to identify the total number of customers in the customer marketing list by the following buckets. Generation. So what generation a customer is in based on their age. Are they silent? Are they a boomer, Gen X, millennial, Gen Z? And whether they have transportation or not. So if they own a bike or a car, they own their own transportation. But if they don't own either, then they don't have any transportation. So exercise 1 says this. Can you write a SQL query that replicates the numbers in the below chart? What do we have here? This is such a cool chart. One of the most powerful things that you can do with SQL is be able to look at a result output or an end chart and then re-architect the code based on what the chart looks like. This is what you might have your business partner do for you. You might have them draw what they want to see as the result output, and then you're going to architect the code based off their picture. So in this case, this is called a stacked bar chart. A stacked bar chart allows you to look at 2 dimensions in one aggregate at the same time. In this case, we have 2 dimensions that we're looking at. We're looking at the generation of the rider and whether they own a transport or not. Qualitative pieces of data. And then the quantitative piece of data is the total number of customers. So we're taking the total number of customers and we're grouping it by their generation and their transport status. You folks know how to do this. These are the numbers that we want to see in a result output. And we're going to be using the trips and the customer marketing list table. The customer marketing list table, just for this first question. So let's hop in here. Exercise 1, we want to recreate this chart. Total customers by generation and transportation status. What do we know about SQL? It always starts with select and from. That's how we get our momentum going. From. In this case, we want to count the total number of customers by their generation and transport status. Those are 3 columns of data that I hear. One of them is total customers, so let's write that in our select statement. Folks, does that sound like a dimension or an aggregate to you? To me, that sounds like an aggregation. It's a quantitative piece of data, so we're going to write ag after it. What else do we want to see? It says we want to see the generation of the rider. Generation, whether they're silent, boomer, Gen X, Gen Z, millennial. We're going to write generation here. Generation, does that sound like an aggregate or a dimension to you folks? That's a custom dimension that we're going to make with a case statement. We'll get to that in a bit. It also wants to see their transportation status. Whether they own a vehicle or not, some kind of vehicle, whether it be a car or a bike or not. So has transportation is going to be our other column. Has transportation, and I'm going to write dim next to it. Easy peasy. Folks, what happens when you mix aggregates with dimensions? You're going to need a group by. So why don't we pop a group by down there? And then what goes in the group by? Only the dimensions. So we're only going to put generation in here and has transportation. Easy peasy. What table are we talking to? Customer marketing list table. That's going to have all this information in it for us, as you see from the schema. Their age, and then whether they own a bike or car. We're going to need these ingredients. So, generation. Generation isn't a column here. It's something we're going to have to make, and its ingredients are the age. So there's a little guide here. If someone's over the age of 75, they're silent. Between 55 and 75, boomer, etc. We have to write a case statement that is going to categorize people based on their age. So a case statement, remember, is a column. It's a column of data. It goes in the select statement, and its output is a dimension. So here, I'm going to write case. I'm going to say case when. I'm going to write case. Every case statement starts with case and ends with end. Case statement starts with case and ends with end. And in here, we're going to write all the criteria in between. When I first started learning case statements, I thought it was more than one column of data in the result output. It's just one column of data in the dimensions. So let's start with this. We're going to start with the silent generation. When the age of the person is greater than 75, you'll notice this looks just like a where clause thing. Then we're going to say silent. You'll notice I wrapped it in single quotes because this dimension we're going to output a string as a result output. So when the age is greater than 75, we're going to say there's silent generation. How do I know this? Well, I have the generation bucketing here, and I'm actually going to paste that right there so I have it right in front of me. That would be really useful for me to look at. So when their age is greater than 75, then silent. Okay, let's look at the next bucket. When their age is between 55 and 75, so let's use between. Remember, between is inclusive. It's going to include the first value and the ending value you put in that range. When it's between 55 and 75, then what are they? They're a boomer. So we'll do single quote boomer because we're outputting a string as our column. Our dimension is going to be a string data type. So we're going to wrap what we want to output in a string. Let's move on to Gen X. When the age is between 40 and 54, 40 and 54, then it's going to be Gen X. And then we're going to do the same thing for millennial. When the age is between 25 and 39, then millennial. I don't know if I spelled millennial wrong. Probably did. I think it's just one L. Millennial. Yep. You'll notice that I'm just writing 25 and 29 for age because age is a float. It's a number, so I don't need to wrap it in single quotes. So all the rules of the where clause, all that syntax rules are coming to the case statement. All right, let's do under 25, Gen Z. When the age of the person is less than 25, then they are Gen Z. And if they're not any of those things, then we write else. Else is the catch-all for when nothing matches. So if they're not any of these things, then they're some kind of unknown generation. Unknown generation. So we're going to write unknown. All right. So we've created this column called generation. See how big it is? That's only one column of data though. But we're creating this kind of custom dimension column that we're going to use later. So what I'm going to do here is I'm going to ask myself, well, how do I calculate the total number of customers from the customer marketing list table? What do we know about the granularity of the customer marketing list table? Every row is a rider ID. So if every row is a rider ID, that means we can just count the rider ID column, and that will give us the total customers. So let's just do a count of rider ID as total customers. And then let's try to run this. You'll notice I put the aliases in the group by because the select statement creates the columns, and then we can recycle the aliases in the group by and the order by because the select statement runs before the group by and the order by. Has transportation doesn't exist. Oh yeah, I forgot to create that column. There is no has transportation column. It's based on whether they own a bike or a car or not. So has transportation, how is that defined? Well, it's right here in the guide. So I'm going to hop back in. I'm just going to paste it down here so I'm going to put it in a comment so I can see what the conditions are. So has transportation is based on this. If they own a bike or a car, they own their own transport. So this is going to be a case statement. What do we know? All case statements start with case and they end with end. Case. So we're going to define whether they own a transport or not. When someone has own bike, that's the column here. When someone has their own bike, and that's equal to true, or someone has their own car, and that's equal to true. These are Boolean columns, so we don't need to wrap them in single quotes. So if one of those two conditions are true for the row, then what do we want to say? Do they have transportation? Then true. We're creating a Boolean column as a result output. This is kind of cool. So if one of these two are true, we're going to say return the value true. Okay. Now, how about if they don't own their own bike or a car? So if has, we'll do the next one condition. When has own bike equals false, and has own car is equal to false, then they don't have a transport. So if both of those are false, then they don't have their own transport. If none of those things are true above, let's just say null. Because we're creating a Boolean column, I don't want to output a string if none of these things are true above. I want to just output a null. Because Booleans only allow true and false. So if I output a string, this thing's going to get all broken. So I'm going to write else null. So I'm going to highlight this code now and run it. Here we go. We get a count of the total customers, our aggregate. We get the generation they're in and whether they own a transportation or not. Let's just make sure this looks good. We should have 95 boomers that have transport. We do indeed. 95 boomers who have transport. Do we have 33 who don't? Yes, we do. What about Gen Z? Do we have 61 that have transport? Yes, we do, and 27 who don't. It's a really great way to check your work. Let's look at the values here. In summary, we've created two case statements, generation and has transportation. And then we're just disaggregating the total count of customers by those customer dimensions. This is really versatile using a case statement. Super versatile. You can make any column that you wish. Let's do exercise 2, second question. So we're going to write a SQL query that replicates, question 2. It says write a SQL query that replicates the numbers in the below chart. Hint, you'll need to join to the trips table. Draw a Venn diagram. Draw a Venn diagram to help. Okay, so what do they want to know? They want to count the total number of customers who haven't taken a ride by generation. Oh my gosh. Whenever you hear that word haven't taken a ride or haven't made an order, what does that sound like to you? An exception join. This is an interesting problem. We're going to do a join with a group by. That's an exception join with a case statement. There's a lot of stuff going on here. So let's just break it down into its components, and we're going to be able to tackle it easy enough. All right. What do we know every SQL query needs? Select, and from. What do I want to build here? I want to look at the total customers who haven't taken a ride by generation. There's 2 columns there. Did you spot the aggregate? You want to count the total number of people who haven't taken a ride and break it out by the generation. There's 2 columns of data that we want to build. So what do we put in the select statement? Total customers, no ride, who haven't taken a ride. And to me, that sounds like an aggregation. The generation of the customer is what we want to put here. That sounds like a dimension to me. Okay. So, the from statement. If we want to find people who haven't taken a ride, we need to look at people who are only in the customer marketing list table. They're only in that one. They're not in the rides table, the trips table. What's the center of the universe, though, in this world? We want to get these 2 tables to talk to each other. We list a primary table first, the left-hand side table, and that is mvaleri12.trips. That's as A, and then what's the other table we want to talk to? mvaleri12 customer marketing list, right? As table B. Nice. Okay, looks good. What do these 2 tables have in common? We're going to write the on condition here. How do we get the trips table to talk to the customer marketing list table? We know they have rider ID in common. So let's say a.rider_id equals b.rider_id. Which kind of join do we want to use? This question says, find me people who haven't taken a ride by generation. If somebody hasn't taken a ride, that means they're only going to be in table B, so we only want to be looking at the right-hand table. So our join is a right join, and more specifically, it is a right exception join again. What do we know about exception joins? Exception joins need a where clause. Right? Exception joins need a where clause. In the where clause, what do? Set the opposite table's primary key to null. We're only looking at the right-hand table. The opposite table is the left-hand table in this case, table A. So we set table A's rider_ID is equal to null. All right. Folks, we're building the shell of the query right now. What happens when you mix a dimension with an aggregate? You're going to need a group by. So let's put a group by down here. Wow, this is quite the question. Generation is going to go in the group by. Generation, remember, is made up of determining the age of the person in table B, the customer marketing list table. That's our ingredient. So where are we going to find the age of the person? In table B, the customer marketing list table. You'll notice I actually wrote this case statement up here. Why don't I just recycle it? There's no shame in just recycling your code. So we've already written it up here. It's going to be the same conditions. So in generation, I'm just going to paste. However, because since I'm working with more than one table, I need to append my columns with the table alias. Where does age come from? Table A or B comes from B. B.age. B.age. Just go through and alias all those. B.age. All right. Total customers no ride. How are we going to find that? Well, we're only looking in the right-hand table. We don't care if we don't need to look in table A. So the customers who have taken no ride, we want to be looking in the customer marking list table, but how are we going to aggregate those people? What column do we need? Well, like I said, that's why I like to open up the table itself. Customer marketing list. Nice. Okay, so if I want to count the number of people in this table, I can use the rider ID column. Let's try that. Total customers, no ride. I'm going to say count the rider IDs in table B as total customers, no ride. What do we know about the customer marketing list table? Every row is a rider ID, so that should be safe to do with no duplication. Whew. So in this query, we have a case statement, we have an aggregate, we have a right exception join, and we're using the group by. A lot going on here. So I'm going to highlight this and run selected, hoping that works. And total customers no ride. Let's see if that gives us the answer that we want. Total customers no ride. 47 for the boomer, 62 for Gen X, 27 for Gen Z, 57 for millennial. Is that what we have? 47, 62, 57, 27. Looks good to me. See if you can do that one on your own. Group activity. Okay. See if you can do this question. Case statements, exercise review. What you're going to do is you're going to count the number of products grouped by family member preference, who has the most options. So you're going to have to look in the products table at a list of alcoholic products, and then you're going to have to say, hey, these many products are what the son would prefer. These many products are what the dad would prefer. These many products are what the mother would prefer. And each member of the family has their own criteria, right? So the son prefers vodka. That's proof is 90 or more. And if it's vodka and it's 90 or more, the son's going to want it. If it's flavored rum and its proof is 90 or more, excuse me, I read this wrong. The son, let me back up. The son prefers vodka products that are 90 proof or more, or he prefers products that are rum and 90 proof or more. So it's either got to be vodka or rum, and they both need to be over 90 proof. He really likes strong drinks, the son. The father says, hey, if the item description has something like the word mint in it, something minty, and it's $25 or less, that's what I want to drink. So the dad likes to drink, maybe the Listerine. The mom says this: if the category is Scotch whiskeys and the bottle price is $200 or more and its proof is 90, she's pretty highbrow. That's something that she would like to drink. So your result output, you're going to see two columns of data here in the select statement. It's going to be select the family member, preference, right? Whether it's a son, father, or mother. And then the count of the number of products. Count of number of products. Those are the two things you're going to want to see in your result output. What table are you talking to? From the mValeri 12 products table. So we're just building the shell of the query. We're not sure anything's built yet. We're just setting ourselves up for success. The family member preference. Does that sound like a dimension or an aggregate to you folks? To me, that sounds like a dimension. So I'm going to write dim next to it. The count of the products. Does that sound like a dimension or an aggregate to you folks? To me, that sounds like an aggregate indeed. So I'm going to write aggregate. All right, what happens when you mix a dimension with an aggregate? You need a group by. So I'm going to write group by here. What goes in the group by? Only the dimensions. So the family member preference column is going to go into the group by because that's the only dimension. Clearly this isn't going to work because if I look at the products table, family member preference is not a column in our result output. It's something that we're going to have to construct using, it's a custom dimension, case statements, and if then else. So let's do select star from mvaleri12.products. Take a look at this table just to see how we're going to have to build family member preference. All right. So it's got bottle price, bottle size. Every row here is a unique product. Its category name, item description. It's a very rich data set of liquor. So I'm going to open products there. All right, so let's construct the case statement for family member preference since it's not a column in here, but we need to use the ingredients from this table to create it. What does every case statement start with? It starts with case. And what does it end with? End. So let's start with the son's preference first, the first when condition. I'm going to say when. And this is laid out really nicely for me, what the son likes. The son says, hey, if that category name is flavored vodka, so when the column, see if we can find it here, category name, when category name equals flavored vodka, what do we know about flavored vodka column? That it is, or category name, it's a string, so we need to wrap it in single quotes. Notice we're following the syntax of the where clause here when we're doing case statements. Very similar. When the category is flavored vodka, and it says its proof is greater than 90. Let's look at the proof column. Oh my gosh, do you notice something here? Proof is a string. It's a string, it's not even a number. So we're going to have to cast proof as something else. Otherwise it's not going to work. We need to convert it into a number. So when proof as an integer, let's try that, is greater than 90. So if it's flavored vodka and the proof is greater than 90, then do what? Then there's another thing here. If it's these things, flavored vodka and the proof is over to 90, or the category name, he also likes flavored rum, so let's try this. And the proof is over 90. What I'm going to do here is I'm just going to put this on a different line because I think it's kind of getting all mashed up. It's a little hard to see. And I'm going to cast the proof again because it's appearing as a string right now, which is no good. So if that's greater than 90. So if one of these conditions is true, who wants to drink it? Then we're going to write son. That's the son's drink. Okay, now we've identified what the son wants. Let's start what the dad wants, which we start a new when condition, because we're going to say if these things are true, then it's for the dad. So for the dad, it says if the item description has something with mint in it. So we're going to look at the item description column. You notice that it says it has to contain the word mint. What do we know about it has to contain some word? We use a wildcard. We need to use like. So when the item description is like mint, we're going to do %mint, %, because anything can come before mint and anything can come after. It's a string, so we wrap it in single quotes. What do we know about item descriptions, though? Well, things can probably be in lowercase, uppercase, mixed case. So to control for that, I'm actually going to convert item description into lowercase. So I'm going to say if the item description, when it's all lowercase, contains anything like the word mint, and the case cost is $25 or less. Oh, that's a column here, right? Case cost. Yep, case cost, it's a float, it's a number. When the case cost is $25 or less, so less than or equal to 25, then this is something that the father wants. So I'm going to write father as a result output here. All right, let's do the mom now. Mother preference. When the category name is Scotch Whiskies. Okay, so when the category name equals Scotch Whiskies, when the category name equals Scotch Whiskies, and the bottle price is 200 or greater. Okay, so let's say the bottle price is greater than or equal to 200. Let's see if bottle price is a number. Yep, looks like it's a float. And the proof is 90 or more. Okay, so it's got to be Scotch. It's got to be greater than $200. And the proof of it's got to be 90 or more. I'm just going to copy this. Everyone in the family really likes high proof alcohol. Then we're going to say mother. Oh, cool. There's the mom. That's what she wants. All right. If none of those things are true, else, I'm going to write no family member wants that drink. Okay, so I've wrote my case statement. Starts with case, ends in end. Each family member gets their own when condition, in which I write a very similar syntax to the where clause to get this thing to work. And then we're outputting a string, whether it's the son, father, mother, or maybe it's neither of them because it's a different drink. To count the number of products, what column are we going to want to use? Well, every row in this table is a unique product, so we could probably count the item number, the unique identifier for the item. So in here, I'm going to write just count, use the aggregate item number as the count of the number of products in this table. All right, let's run this code and see what happens. Nice. Okay, so what I've done here is I've gone through the entire products table, and it looks like there's 10 products that meets the son's condition. Flavored vodka over 90 or flavored rum over 90. For the father, he's got 7 products that meet his condition, right? It's got to be mint in case cost less than or equal to 25. And then the mother, there is 3 products that meet her condition in that table, and then the rest of the products don't meet anyone's condition in that table. Let's say you wanted to know which products are for the father. Well, all you would need to do is just throw this in the where clause. Throw that in the where clause, and then you'll find out the products that the father wants. I could even show you here in the code. Let's see what those products are. Let's just do a select. It's really interesting when you use a case statement. You're just bringing the where clause up into the select statement, and it's creating a column for you. Select star from mvaleri12 dot products where the father's conditions are true. So that's when the item description is like mint and the case cost is less than 25. So I'll throw that in there. Then you folks can see that there is indeed 7 products in there that the father would want. All right, there's the 7 products. Peppermint schnapps. Oh boy, that sounds horrible. I've not been able to drink peppermint schnapps since I was 21 years old. I don't think I'll ever drink them again. Whew, they are rough, rough, rough. Jim Beam, no thank you. but that's what the dad wants. So what do we do here? We aggregated something and we created a case statement around it. Don't be afraid of case statements. They're just dimensions that you custom create based on criteria, and you're using the same syntax as the where clause. Really, really powerful. Okay, let's look at this. This question says, can you count the number of products for each family member, represent each member's product as its own column of data? What the heck does that mean? Well, let's run this code again, and I'll illustrate it using Excel, and I think that'll help a lot. I'm going to open up Excel. Microsoft Office is going to tell me that everything's expired. I apologize. It's really annoying when it does that. Okay, so there's a result output of our query, right? What is this column called? It's called the family preference. And it was a dimension. It's something that we created. It's qualitative. This is the number of products. It's an aggregate. It's a custom, or excuse me, it's an aggregate. It's something that we made. This question's asking us to just restructure the result output. So what it wants us to do is, instead of grouping things here horizontally by son, no family member, father, mother, it wants us to create our own custom column, which is a new table that would look something like this. It's also called a pivot. We're going to pivot the data in a different way. Number of son products is a column in this new table. Number of father products is a new column in this table. And then what's another one? Number of mother products is a column in this table. There we go. What number should we see here in these columns? Well, the number of son products is what? 10. The number of father products is what? 7. Number of mother, 3. The number of son products is a dimension or an aggregate. Well, the number of son products sounds like an aggregate to me. The number of father products sounds like an aggregate to me. And the number of mother products sounds like an aggregate to me. So this is one version of our result output in which we use a dimension and an aggregate. And then we want to create this version of a result output in which every column is an aggregate of the son, father, and mother products. Same numbers, just restructured differently. You'll notice something. There is 1, 2, 3, 4 rows of data here. And then in this case, there is one row of data in the result output, which is just the number of products for each person. Sometimes you want to pivot your data because you want to eliminate or reduce the number of rows in the result output. This becomes really important when you're working in a visualization tool like Tableau or Power BI, in which you can only consume so many rows of data before the thing becomes less performant. So once you get over, like, say, 700,000 rows in either of those tools, things just start to go downhill. So using a pivoting of data, where you're able to pivot it in a different structure, you can go from a 4-to-1 ratio. You can reduce your number of rows to 4-to-1, which is really, really useful. So what we're going to do is we're actually going to create 3 aggregate columns: number of son products, number of father, and number of mother. So let's jump back into Mode Analytics and relook at the question. What do we know about every SQL query? You need select, and you need from, right? Count the number of products for each family member, represent each as its own row of data. In our select statement, we know we're going to want a column called son number of products. Folks, what does that sound like to you? A dimension or an aggregate? To me, it kind of sounds like a little of both. But let's just say it's an aggregate for now. It's just the number of products. Then we want one called son or father number of products. And we're going to say that's an aggregate 2. And then we've got mother number of products, which is an aggregate as well. What table does this come from? mvaleri12.products, right? mvaleri12.products. So son number of products. How are we going to calculate that? Well, what do we know? We know the son. What makes something a son product is, well, the case when, what's true? This. It's vodka greater than 90, it's flavored rum greater than 90. Then it's something the son wants. So why don't I just say, when the category name equals flavored vodka, or the category name equals this, then let's return the number 1 else null. End as the son number of products. So when we find a son product in our table, let's return the number 1. And if we don't find it, let's return null as a value. And then heck, why don't we sum all the ones? And this is what we call a conditional aggregate, or nesting a case statement inside of an aggregate function. Incredibly powerful. What you can say is, if these things are true, add up these numbers. So what we've done is we've nested a case statement inside of an aggregate function. And what we said is that if these things are true, if it's a son product, if you return the number 1, then it's a son product. And if you haven't, it's null. And then we say end. Then we're going to sum all the ones, and that would tell us the number of son products. We're going to do a very similar thing here with the father. Since these are all aggregates, we know we're going to be using some aggregate function, so I'm going to say sum as father number of products, sum as mother number of products. What does the father want? It's up here. Got to nest a case statement here. Case when these things are true, then return the number 1, else return nothing, end. What do you know about sum? Sum ignores nulls. So if it finds a row where these conditions are true, we're going to return the number 1, and then we're going to sum it. So we're going to get the sum of the products where those are true. Mother number of products, same thing. Case when end. What does the mother want? Here's the mother's conditions. I'm just going to zoom out here. Case when Scotch whiskey's bottle price is this. The proof of it is greater than 90. Then return the number 1, else 0. End as the mother number of products from the mvaleri12.products table. These are all aggregates. What we've done is we've nested a case statement inside of an aggregate, and we use it so we can pivot data to create less rows of it. This is particularly useful if you're ingesting data into a tool. It hates it. I said some case when this, then else null end. Category name equals flavored vodka. Case when category name equals flavored vodka, and this is greater than that, or the category name is this, and that is greater than that, then one else null end. syntax error near sum. You don't get it right every time. Let's see if I can debug this. So it's telling me there's an error with my son number of products. So I'm just going to remove these and try to run this code again. Okay, the son number of products is 10, which is what we want. So I've just eliminated these. And for some reason it didn't like the father number of products. So I'm going to bring that in now. I just remove it with the 2 dashes that highlights the code. Okay, there's a father number of products. Let's do the mother. Doesn't like the mother for some reason. Let's try that. I don't know what in the Sam Ellington was going on there, but it didn't work at first, but now it's working. So all I've done is I've just pivoted my table from this version to this version, and that's called nesting a case statement in an aggregate. I think it's pretty advanced, and if you know how to do it, you can really create a lot of efficiencies in your code, especially when you're aggregating data. There's lots of questions on the homework about that. In fact, the homework's over. We're moving on to the Sql Midterm Review. And the Sql Midterm Review is something I'm going to go over in the next video, because all your homework now and assignment is moving out of the homework world into the SQL Immersive Skills Assessment right here. Your homework is actually going to be working on the skills assessment, and I'm going to talk about it in our next video in depth. Thanks for joining us, talking about case statements, and we'll see you soon. Bye.